So in this last problem, we're given some information about a potato being taken out of a pot of boiling water. It tells us when the potato is taken out, the temperature is 91 degrees. It says the internal temperature of the potato is always greater than 27 degrees. And then it gives us a differential equation that models the temperature of the potato. Part A is asking us to write an equation for the line tangent to the graph of h at t equals 0, and then use that approximation to estimate the internal temperature at t equals 3. So if we're writing an equation of a tangent line, we're going to use point slope form. Y minus y1 equals m times x minus x1. Well, we already know a point because it tells us to use the point when t equals 0. So that's when the potato was first taken out of the water. So that point is going to be 0 minutes, 91 degrees. All we need then is the slope. Well, the slope is going to be given by this dh dt here. That means the rate of change of h with respect to time. So we're going to find dh dt at the moment when t equals 0. So that's going to equal negative 1/4 times. Now be careful here, we're not just plugging in 0 for h, because this isn't when h equals 0, it's when t equals 0. So when t equals 0, that h is actually 91. So 91 minus 27. So simplifying, 91 minus 27 is 64. Negative 1/4 times 64 is negative 16. So this is our slope. So now that we know that, we can use it to write the equation of the tangent line. So we're going to use y minus 91 equals m, this slope, negative 16, times, since our independent variable here is time, I'm going to replace x with t, minus 0. So this is the equation of the tangent line. If you want to simplify it to y equals negative 16t plus 91, that works as well. And then finally, it's asking us to use this tangent line to estimate the internal temperature of the potato at time t equals 3. So just plug in 3 for t then. Then we'll get h will equal negative 16 times 3 plus 91. And you can use a calculator for that if we need it. That should come out to 43 degrees Celsius. Make sure we always include a unit there. It didn't specify that we needed to have it, but it's always a good idea to have it. So this was a 3-point problem. You got 1 point for finding the correct slope, 1 point for the equation of the tangent line, and 1 point for your approximation of 43 degrees Celsius there. And then finally in part B, it's asking us to use the second derivative to determine if your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at t equals 3. So if we think of what this second derivative really tells us about a function is its concavity. And we can use that to determine if something is an underestimate or an overestimate by really just imagining the graph. If something is concave up, then at any point on that graph, the tangent line is below the graph. So that's going to be an underestimate. Whereas if the graph is concave down, then at any point on the graph, the tangent line will be above the graph. And that will give us an overestimate. So if we can determine the concavity of h, then we can determine if our answer from part A of 43 degrees is actually a little too high or a little too low. So we need to start by taking the second derivative of h. Well, this up here was the first derivative. So we just need to take the derivative of that. And before we do that, I'm going to simplify it. I'm just going to distribute this negative 1/4. So we're going to be taking the derivative of negative 1/4 h plus 27/4. Which that derivative really is pretty easy because the derivative of negative 1/4 h is just negative 1/4. And the derivative of a constant is 0. But don't forget, we're taking the derivative of h with respect to time. So we need to include dh dt in here. Which dh dt is this function up here again. So we're going to have negative 1/4 times negative 1/4 is going to end up being positive 1/16 times h minus 27. So that's what d squared h dt is equal, dt squared, the second derivative is equal to 1/16 h minus 27. What this problem is asking us to do is evaluate this at t equals 3. But we're kind of going to run into a problem with that because we don't know the temperature of the potato at t equals 3. But what we do know is that this temperature is always greater than 27 degrees. So doesn't matter what time we're at, h is going to be bigger than 27, which means when we subtract 27, we're going to come out with a positive answer. So d squared h dt squared, the second derivative, is always positive. Because h is always greater than 27. So that means h must be concave up, and therefore our approximation is an underestimate. So just to answer the question, I would write the approximation in part A is an underestimate for concave up, is an underestimate because h is concave up, and then I might even clarify because the second derivative is positive at t equals 3. So this was actually only a 1-point question. You had to tell whether it was an overestimate or an underestimate and provide the reason in order to get the point. So we would need all of this in order to get the 1 point here.